Towards the end of the digging, we got our first gravel delivery, which I then proceeded to move up in 5-gallon buckets with the materials hoist. I had just a little bit more digging to do to make clearance for the drain before compacting the soil and gravel around a wood form that would keep the gravel in place until I was ready to put in the lower insulation panel. The panel was constructed in one piece. The horizontal layers are Owens Corning Formular 600, which is 3 inches thick, and that has a high compressive strength of 60 psi. It's likely that this hot tub, when it's fill with water, is going to be about 15,000 pounds or thereabouts. The panel was glued with polyurethane glue, and once dry, fitted into the bottom of the gravel bed. Next, the lower footwell insulation was built on the walls, which is basic 2-inch rigid foam. And at this time, I fit the pipe that transitions from the plumbing trench into the lower footwell. This was some tricky fitting to get everything to line up, but after it was all set, I wrapped it and put expanding insulation around those pipes. More buckets of gravel to fill the seat level. Anytime you see me with that stick, that's a story pole with elevation markings that I check against the laser set up on one of the posts for the tent at a consistent level. Next, I built the insulation layer for the seats using every last scrap of the 3-inch foam and sealing the gaps with expanding foam. Then on to the upper tub wall insulation. All this insulation is, of course, to limit the conductive heat loss into the ground from the hot water. I set up some reference lines for the tub centers to lay out the forms for the back deck slab. I had to trim the drain line a little bit, but I'll rebuild that after the pour. And again, more buckets of gravel and height checks for the deck slab. The whole area received a layer of 6mm poly as a vapor barrier. I found that using 3M90 spray adhesive on the poly worked well if you let the solvent evaporate a little bit before sticking it to the expanded polystyrene foam. Otherwise, it'll start to dissolve the foam. So all the formwork on this tub is at 60-degree angles, or 30-degree miters. And since we're planning on a single staged pour, all the forms have to be able to float on minimal supports in the hull, and plus they got to withstand the hydraulic pressure of the concrete. I built the lower footwell form outside of the hull so I could get accurately placed joints, and then I put it in the hull to check for fit and rough in the water return. Here's a better shot of the backside showing the 3 return jets and clearance for the light niche tubes. Alright, this here is not going to fly. This form was getting really heavy and I needed a way to maneuver it in and out while fitting the drain plumbing. So I set up a little rope hoist to hold the lower form and I could bring it up and down. The drain needed to be held flush with the bottom edges of the form, so once it was aligned I built a fixture which attached to the top of the drain and held it in the exact right height, which allowed me to fit the rest of the plumbing. There you see the wooden supports holding the drain in place and the adjustable threaded rods that I used to level the formwork in the hole. Next, I could prepare the supports for the upper wall forms. Since each of these had 2 jet tubes, I added metal angle brackets outside the holes to support them. Fitting these forms was a pain. Each of the 6 sections had its own threaded rod, and it took some iterations of fitting the corners to get everything together, lined up, and at the right height. I was constantly checking the angles, the height, and the level, as it is critical to get this shape accurate so that the tile goes in quite cleanly. A little discussion with the clients before moving on to fix a mistake that I made on the size of the area for the skimmer. So I really just had to trim out the foam, dig the hole a little larger, and then rebuild the foam and vapor barrier to give enough clearance around the skimmer for the concrete. The hoist was really helpful as I was able to fit the drain plumbing and then pull the form out to build the lower rebar grid. And then I could lower it back to check for fit and clearance. For the most part, I'm using 1/2-inch rebar, which is number 4, on a 12-inch grid. After the lower rebar was in place, I used spacer blocks to center the lower form inside the upper form and finish up the drain plumbing and the light niche conduit runs. On the recirculation line, we installed this, which is a bonding pipe. During the research, we found that it's typical to bond the water itself of a pool to a hot tub. This is commonly done through the large underwater light niches or the railings for the stairs. But because we're using all plastic LED lights, we need another way to bond the water. This is a bronze pipe that's epoxied to PVC couplings and has a stainless steel grounding clamp. This will be linked with the bonding wire, which also ties into the rebar grid that surrounds the hot tub. The LED pool lights fit into a 1.5-inch threaded return fitting, and those in turn fit into a 2-inch PVC tubes that are bonded to the basic 3/4-inch PVC electrical conduit that runs back to the pump house. While finishing the electrical rough-in, I ran a pulling string through all the conduit to aid in fishing the wire. Finally, the lower plumbing was complete, and I could move on to test fitting and sizing the parts for the jet plumbing. I think that's enough for now. In the next video, we'll finish up the plumbing, the forms, and the rebar in preparation for the big pour. Thanks again for watching.